Good morning everyone. I'm Diksha Bajaj. Today we are going to discuss about the colloidal state of a matter. So firstly, what are colloids? It is a state in which the size of particle is intermediate within 1 to 1000 nanometer. And the particles can pass through a filter paper but not through the vegetable or animal membrane. So basically we have three types of solutions which you have studied from your many classes from a ninth itself. That is, three types of solutions are there. So let us discuss what are the three types of solution. First is your true solution. Second is your suspension. And the third is your colloidal. Third is your colloidal solution. So basically we are going to discuss about the true solution, suspension and the colloidal. True solution are the homogeneous solution, while the suspensions are the heterogeneous and the colloidals too are the heterogeneous in nature. What does homogeneous means? अगर मैं sugar ਨੂੰ ਪਾਣੀ ਦੇ ਵਿੱਚ dissolve ਕਰਾਂ ਤਾਂ I cannot see a separate layer of both. Sugar would be completely soluble in that of a water. Similarly, the salt is completely soluble in a water. That is an example of a true solution. So it contains a small particle dispersed through a water solvent. Particle size is less than 1 nanometer. Yes, the particle size is very less, extremely less. So that's why we are unable to see them even under the microscope. They can pass through the filter paper too. So it means we cannot separate them if they can be visible through microscope. So they are very minute in nature. That's why they can pass through a filter paper. We cannot separate them. While in suspension, it is a heterogeneous in nature. What does heterogeneous stand for? ਜਿਵੇਂ ਕਿ ਆਪਾਂ ਮਿੱਟੀ ਨੂੰ ਪਾਣੀ 'ਚ ਪਾਵਾਂ, chalk powder in a water. I cannot mix them completely. There would be always a separate layer. ਜਿੰਨਾ ਮਰਜ਼ੀ ਮੈਂ mix ਕਰਦਾ ਇੱਕ chalk ਨੂੰ पाउडर ਨੂੰ ਪਾਣੀ 'ਚ ਪਾ ਕੇ ਤਾਂ ਅਲਟੀਮੇਟਲੀ ਆਫਟਰ ਸਮ ਟਾਈਮ ਦੈਟ ਵਿਲ ਸੈਟਲ ਡਾਊਨ. ਜਿਹੜਾ ਚੌਕ ਪਾਊਡਰ ਹੈਗਾ ਨੀਚੇ ਸੈਟਲ ਕਰ ਜਾਏਗਾ, ਮਿੱਟੀ ਹੈਗੀ ਉਹ ਨੀਚੇ ਸੈਟਲ ਕਰ ਜੂਗੀ. ਐਂਡ ਦਿਸ ਇਜ਼ ਐਗਜ਼ਾਮਪਲ ਆਫ ਹੈਟਰੋਜੀਨਸ ਇਨ ਨੇਚਰ. ਦੇ ਕੰਟੇਨ ਦ ਇਨਸੋਲੂਬਲ particle size is more than 1000 nanometer and they can be visible through the naked eyes and cannot pass through a filter paper. If the size is very large, how it can pass through a filter paper? So they can be separated by it. Next is your colloidals, which we are talking about. It is a heterogeneous solution. The particle is intermediate in size as that of a true solution and suspension. The particle size is an intermediate of 1 to 1000 nanometer and they can be also seen through a microscope, but it is a ultra microscope. So the example here is milk, right? And here example is soil in water, and here example is sugar in water. So hopefully you have understood what is the basic difference between the true solution and suspension and a colloidal solution. Now we're going to discuss about the phases of colloids. There are two things like that of sugar in water. है ना, एक example लेके चलते हैं, but sugar in water example of a true solution, but just make it understand. Like a sugar is a solute and water is a solvent. So in the other cases, sugar which is present in a less amount is called as solute. And here in the case of colloids, the something which is present in a small amount, that is called as dispersed phase. And water, the solvent where it is greater in a greater amount, that is called as dispersion medium. So what is dispersion phase and dispersion medium? Indirectly a solute and a solvent, right? Something which is present in a lesser amount and a greater amount. So basically it's a component present in a small proportion as a solute in solvent, and it is a component present in excess, that is a solvent in solution. जो चीज वध मात्रा च होगी, that is called as a solvent, and this is called as dispersion medium in the case of colloids, and which is called as a solute in case of a solution, that is called as dispersed phase in the case of colloids. Here the example is going to be the colloidal solution of silver in water. Water is a solvent and the solute is silver. So that is a dispersed phase. And the dispersion medium which is in a water, that is your dispersion medium. Now we're going to discuss about the classification of colloids. The first is physical state of dispersed phase and dispersion medium. The second is nature of interaction between dispersed phase and the dispersion medium. And the third is the type of particles of dispersed phase and dispersion medium. So basically we have the dispersed phase and the dispersion medium and the type of colloids. So let us discuss what are they. When the solid is dispersed in solid sol, that is called as solid is dispersed in a solid, that is called as solid sol. When the solid is disposed in liquid, that is called as a sol. When the solid and the gas, that is called as aerosol. When the liquid is disposed in solid, that is called as a gel. Liquid in liquid is called as emulsion. Liquid in that of a gas is called as aerosol. Gas in solid is called as solid sol, and the liquid in gas, that is called as a foam. So basically we are characterized with. So let us discuss the examples of it. So solid in solid, that is a solid sol. The example is alloys, colored glasses, gemstones. When the solid is disposed in liquid, that is called as a sol. Solid in gas, that is called as aerosol, that is a smoke and the dust. Liquid in solid, that is called as a gel. Example is jelly, butter. ਆਪਾਂ ਹਰ ਰੋਜ਼ ਖਾਂਦੇ ਆ butters, ठीक है, तो क्या है कि that is a gel. Liquid ਕਿਹਦੇ ਚ ਹੁੰਦਾ ਹੈ? Solid ਦੇ ਅੰਦਰ ਹੁੰਦਾ ਹੈ. Liquid in liquid, that is called as emulsion. One of the most important of the board exam emulsions, that is liquid is disposed in liquid. Example is milk, hair cream, emulsified fats. Liquid in gas, that is called as aerosol. The example is mist, fog, clouds. Gas in solids, gas is in a less amount and solid is a greater, that is called as a solid sol. And the example is foam rubber, जो ਆਪਾਂ shaving ਦੇ ਵਿੱਚ use ਕਰਦੇ ਹਾਂ. Gas in liquid, that is called as a foam. And this is the soap leather, ਝੱਗ ਜਿਹੜੀ ਹੁੰਦੀ ਹੈ soap ਦੀ, froth ਹੋ ਗਈ, whipped cream ਹੋ ਗਈ, soda water ਹੋ ਗਿਆ. So all these are the physical, the first point, the physical states of the colloids. So basically, depending upon the nature of dispersion medium and dispersed phase, they have been subcategorized. So if it is a dispersion medium is water, if I have said you is dispersion medium is water, then it is called as hydrosol. If it is alcohol, it is called as alkosol. It is called as alkosols. And if the dispersion medium is benzene, that is called as a benzosol. And if it is air, then it is called as aerosols. So basically, according to the dispersion medium, they have been categorized into the different names. Water is a hydrosol, alcohol is alcohol sol, benzene is called benzosol, and air is called as a aerosol. Now we'll discuss about the nature of interaction between the dispersed phase and the dispersion medium. So nature of interaction मतलब किमें एक दूसरे नाल वो जुड़ते ने. How they have been interacted. There are two one. That is lyophilic and the lyophobic. You know all both the things. What is lyo? Lyo means liquid. Philic means love. And one is lyophobic, that is liquid hating, right? So let us discuss the both. So what is basically the lyophilic colloids? Lyo means love, right? So it's a love and affinity of a dispersed phase and dispersion medium. So the colloid solution in which the particles of dispersed phase have a great affinity, they have a great love for the dispersion medium, that is called as lyophilic colloids. These are reversible in nature and are stable. Why? What does reversible means? The solutions are easily formed and they are reversible. This means that sol is an important characteristics of lyophilic sol. Dispersion medium is separated from the dispersed phase. मतलब अगर मैं separate करना चाहवां dispersed phase से dispersion medium ਨੂੰ ਆਪਾਂ ਕਰ ਸਕਦੇ ਹਾਂ. The sol can again form a simple on remixing. अगर दोनों ਨੂੰ mix ਕਰਾਂਗੇ ਤਾਂ ਦੁਬਾਰਾ ਬਣ ਜਾਊਗਾ. So these sols are quite stable. मतलब कि separate नहीं ਕਰਦੇ है कि they are quite stable and cannot easily be coagulated. We cannot coagulate. जमा नहीं सकते जिਵੇਂ ਦਹੀਂ ਜੰਮਦੀ ਹੈ ਤਾਂ ਉਵੇਂ ਜਮਾ ਨਹੀਂ ਸਕਦੇ ਹੈਗੇ ਇਹਨੂੰ. In case of water act as a dispersion medium, these are called as lyophilic colloids and the examples are gum, gelatin, rubber, proteins, starch. All these are the lyophilic colloids. So let us discuss about the lyophobic colloids. What is lyophobic? Phobic means repelling or which has a no affinity of a dispersed phase and the dispersion medium. So these colloids have a no affinity between particles of dispersed phase and the dispersion medium. They are quite unstable in nature. They are easily precipitated by a small amount of electrolyte. मतलब अगर मैं same charge पाऊंगी तो ultimately we can separate them, we can precipitate them, they can form an insoluble mass on it, and these are irreversible in nature. We cannot separate the dispersed phase and dispersion medium here in the case of lyophobic colloid, and they do not they show the Tyndall effect while that of lyophilic do not show a Tyndall effect. So the third classification is classification based on the type of particles of dispersed phase. So this is a very important topic for the board exams, that is a classification based on the particles of dispersed phase. First is multimolecular, associated colloids and the macromolecular colloids. So what is multimolecular colloids? Multi, as the name indicate, it would be group of many molecules. So when on dissolution, atom or smaller molecules having a diameter less than 1 nanometer aggregate together to form a particles of colloidal dimensions, that is called as multimolecular colloids. So what is multimolecular? So on dissolution, जब आप मिलाने हैं, आप खोलते हैं atom या molecule of a substance जिन्हां the diameter is less than 1 nanometer, means they are extremely small particle, they aggregate together, multimolecular, they aggregate together to form a particles of colloidal dimensions. For example is a gold sol and acid molecule, that is called as multimolecular colloids. One of the favorite topic of the board exams, multimolecular, associated and the macromolecular colloids. So what is basically the macromolecular? Macro means bada, right? Big molecules. So the substances having a big size molecule which on dissolution, जब आप किसी चीज ਨੂੰ खोल दें, they form a solution in which the dispersed phase particle have a size in the colloidal range, right? बड़े particles ਨੂੰ ਆਪਾਂ ਤੋੜਨਾ ਹੈ ताकि ਉਹਦਾ colloidal range particle ਬਣ ਜਾਏ. ਪਹਿਲਾਂ ਆਪਾਂ ਪੜਿਆ multimolecular. Multi means ਛੋਟਾ ਸਾਈਜ਼ ਹੈ, ਉਹਨੂੰ ਆਪਾਂ ਜੋੜਨਾ ਹੈ ताकि colloidal range particle ਬਣ ਜਾਏ. Macro means बड़ा है, उन्हों आपा तोड़ना है ताकि वो colloidal range particle बन जाए, that is called as macromolecular colloids. The example naturally occurring are starch, cellulose, proteins and many artificial polymers also. They are also macromolecules. They have a large size, large mass and they are stable and resemble to that of a true solution. So what is basically, their solutions are quite stable and resemble the true solution in many aspects. For example, protein, starch, cellulose, what are these? These are macromolecular colloids. So what is basically the associated colloid? One of the most important. The substance which when dissolved in medium behave as normal electrolyte. अगर ता ओही substances अगर कट मात्रा दे विच हैगे ने, they will behave as a electrolyte. You all know what is electrolyte. Electrolyte means which can dissociate into charges and which can conduct electricity. So जो चीज charge दे विच separate कर सकती है, that can conduct electricity at a low concentration, but that will behave as electrolyte when it is present in a low concentration, but behave as a colloidal particle at a higher concentration due to aggregation, and you know that aggregated particle is called as a missile. So अगर ता कट मात्रा च है, that behave as a electrolyte, अगर ज्यादा amount है, it will behave as a colloidal. So basically what is multi? Join to form colloidal range. This is to break to form a colloidal range. When in a less amount it behave as an electrolyte, when in a greater amount that is called as that becomes a colloid, and it forms an aggregated particle that is called as a missile, as the soap, right? So the example is sodium stearate, which is a soap. It is going to give on dissociation stearate particles and the sodium particles, right? So what are these missiles? Missiles are the cluster. You all know that this is a working mechanism of soap. This is a grease particle on which there is a aggregation of the soap particles, right? They will behave like an aggregated particle, and this is a sodium ions, the positive addendums which are present at the end, and this is a hydrophobic and this is a hydrophilic end. So this is how they aggregate, and this is called as a missile formation. So let us discuss the craft temperature, an important term. What is craft temperature? अगर आप कपड़े धोंदे हैं, because missile ता soap and detergent बन सकता है, अगर आप कपड़े धोने हैं तो अल्टीमेटली वी नीड सम अमाउंट ऑफ टेम्परेचर. अगर ठंडा पानी होगा देन वी कैन नॉट वॉश आवर क्लोथ्स इन अ दैट मच इफेक्टिव वे एज दैट ऑफ अ lukewarm water does. So the temperature ਜਿਹਦੇ ਵਿੱਚ ਮਿਸਲ ਬਣਨਗੇ, so formation of missile take place above a particular temperature that is called as craft temperature, and it is denoted as KT, that is a TK, and this is called as craft temperature, and above a particular concentration. अगर आप कपड़े धो रहे हैं, can a pinch of a detergent can wash a cloth? No, it is not possible. Can a greater amount can wash a clothes? No, it cannot. So you need a particular temperature and particular concentration by which you can wash the cloth. That concentration is called as critical missile concentration. Hopefully you understood this part. From tomorrow we are going to discuss about the mechanism of missile formation.